Welcome to the second installment in our Release 19 3GPP specification presentation series. This PowerPoint summarizes key 3GPP specifications, distilling essential information through concise visual aids and accompanying narration. My aim is to alleviate the reading fatigue often associated with these comprehensive, yet sometimes challenging documents. By offering this audio-visual format, I hope to provide you with a clear understanding of the specification's core messages, allowing you to grasp the fundamental concepts without initially delving into the granular details. This approach is designed to offer an accessible overview, reserving in-depth document consultation for when implementation specifics are required. If this presentation succeeds in delivering valuable insights while maintaining your engagement, I will have achieved my objective of making these technical standards more approachable and comprehensible. This presentation on the 3GPP Technical Spec 22.156 version 19.1.0 was published in March of 2024. It focuses on mobile metaverse services under stage 1 of release 19. This document is a part of the ongoing work within the 3GPP, which aims to standardize mobile communications. The specification hasn't been approved for implementation yet, but sets the groundwork for future development. The primary objective of this specification is to outline the service and performance requirements necessary to facilitate enhanced extended reality, XR in short, services, which include augmented reality, AR, virtual reality, VR, and mixed reality, MR. These services are collectively referred to as the mobile metaverse. This document is actually rather short, relatively short, comparing with other 3GPP specs. So there are only 13 slides on this presentation. It's much shorter than the last one. If people have sat through the last one, they may say, oh, is this going to have 50 slides? No, 13 slides. The purpose of this technical specification is to define the service and performance requirements necessary for enhancing XR-based services, extended reality-based services, within the 5G ecosystem. These requirements are essential for enabling a robust and immersive mobile metaverse experience which integrates various interactive and immersive media. The scope of this document includes several key areas: localized mobile metaverse services, avatar-based real-time communication, digital asset management, and the operational efficiency, exposure, and coordination of these services. Each of these areas is critical for ensuring that the mobile metaverse can function effectively and meet user expectations. By addressing these components, the specification aims to provide a comprehensive framework that supports diverse service enablers within the 5G system. This framework will help service providers deliver consistent and high-quality mobile metaverse experiences. Additionally, the specification emphasizes the need for interoperability and flexibility. It ensures that different metaverse platforms can work together seamlessly and that service providers can adapt their offerings to meet the evolving needs of users. By setting these standards, 3GPP aims to foster innovation and drive the widespread adoption of mobile metaverse services. The term metaverse in this context refers to shared interactive spaces that users can perceive as persistent and immersive. These spaces leverage AR and VR technologies to create environments where users can interact with digital and physical elements seamlessly. Metaverse services can be categorized into two main types: location-independent and location-specific. Location-independent services provide user experience that are not tied to any physical location, allowing users to interact with virtual content from anywhere. In contrast, location-specific services are tied to particular physical locations and provide augmented experiences relevant to those locations. The primary focus of this specification is to ensure that these services function consistently and efficiently over mobile networks. This involves defining requirements for service enablers that support these immersive experiences and ensuring that they can be delivered reliably across different network conditions. This specification also addresses the technical challenges associated with delivering these services, such as ensuring low latency, high reliability, and efficient resource utilization. By setting clear performance and operational requirements, the specification aims to create an environment where mobile metaverse services can thrive, providing users with seamless and engaging experiences. Operational efficiency is a critical aspect of the mobile metaverse, ensuring that services can be delivered effectively and sustainably. One of the key requirements is the ability to adjust communication services flexibly based on the type of devices being used and the duration of the communication. For instance, wearables and devices with limited battery life need mechanisms to reduce energy consumption over extended periods. Coordination of data flows is another important requirement, particularly for applications involving digital twins or situational awareness services. These applications rely on synchronized data from multiple sensors and media sources to create accurate and real-time representations of the physical world. The specification also emphasizes the need for exposing network performance information to authorized third parties. This allows service providers to monitor and optimize the performance of mobile metaverse services, ensuring that users have consistent and high-quality experience. Finally, the ability to combine diverse media from different services into a cohesive localized experience is essential. This ensures that users can seamlessly interact with multiple types of media, such as AR content, video, and audio, in an integrated manner. These requirements are required to support a wide range of use cases, from entertainment and gaming to industrial applications. By providing the necessary flexibility and coordination mechanisms, the specification ensures that mobile metaverse services can meet the diverse needs of users and deliver a seamless and immersive experience. Specific functional areas include localized mobile metaverse services, which provide immersive experiences that are tied to specific physical locations. These services use AR and MR, augmented reality and mixed reality media, to enhance the user's interaction with their environment, making the digital content relevant to their physical surroundings. Spatial anchors play a critical role in localized services. These spatial anchors create associations between specific locations in three-dimensional space and the relevant service information. By using spatial anchors, users can discover and access localized services such as AR content in a museum or shopping mall based on their physical location. On this specification, it outlines the requirements for defining and exposing spatial anchors and maps. This includes providing mechanisms for creating, modifying, and deleting spatial anchors, as well as exposing spatial localization information to authorized third parties. These capabilities ensure that localized services can be effectively managed and accessed by users and service providers. In addition, the specification addresses the need for precise localization and mapping to support these services. By leveraging sensor data and spatial maps, the system can accurately determine the user's location and orientation, enabling seamless integration of digital content with the physical environment. This ensures that users can enjoy a rich and immersive experience that is contextually relevant to their surroundings. Avatar-based real-time communication is a cornerstone of the mobile metaverse, enabling users to interact with digital representations of other users in an immersive and interactive manner. These services provide real-time feedback to support conversational XR, extended reality, communication among multiple users simultaneously. The specification supports multimedia conversational communications that include real-time avatar media and audio. This allows users to see and hear each other in a virtual environment, enhancing the sense of presence and interaction. The system also supports transcoding between different media types, ensuring that users with varying device capabilities can participate in the same conversation. A unique feature is the ability to identify avatars and associate them with specific subscribers. This ensures that the digital representation of a user is consistent and recognizable across different services. Additionally, the system uses predictive models to compensate for communication latency, providing a smoother and more synchronized user experience even when there are delays in data transmission. The specification also addresses the need for accessibility, ensuring that avatar-based communication can be used by individuals with disabilities. This includes support for text-to-speech and speech-to-text conversion, as well as the ability to translate gestures and facial expressions into avatar animations. By providing these capabilities, the specification ensures that avatar-based communication is inclusive and accessible to all users. Digital asset management is another topic here. This is essential for the mobile metaverse, digital asset management, as it involves handling various types of personal and service-related data. Digital assets include user identifiers, avatar parameters, configuration information, and other data that users need to access mobile metaverse services seamlessly. The specification provides mechanisms for storing and managing digital assets securely. It allows users to associate their digital assets with different user identities, giving them control over how their data is used across various services. Secure access and update mechanisms ensure that users can manage their digital assets safely and efficiently. Interoperability of digital asset formats is crucial for ensuring that assets can be used across different metaverse platforms. The specification requires support for at least one common avatar format to enable this interoperability. Additionally, users can define conditions to restrict access to their digital assets based on factors like location, and authorized third parties can request specific formats of digital assets as needed. The specification also considers the regulatory and privacy implications of managing digital assets. By adhering to relevant laws and regulations, the system ensures that users' personal data is handled responsibly and securely. This includes providing mechanisms for users to control who can access their data and how it is used, ensuring that their privacy is protected at all times. Performance requirements are critical for ensuring that mobile metaverse services can deliver the expected user experiences. The specification outlines several use cases that require specific performance levels, including traffic flow simulation, collaborative engineering, and teleoperated driving. Now, again, for specific KPIs, for specific clauses and limitations, restrictions, and such, those numbers, you need to go back to the spec and look at them when you implement this spec. So the presentation here is functioning as an overview to tell you what is there in the spec so that you know what and where to look for them. I think you already know that. Let's get back here. For traffic flow simulation and situational awareness, the system must handle real-time data from various sensors to model and guide vehicle and user behavior efficiently. This use case requires low latency, high data rates, and high reliability to ensure accurate and timely information. Collaborative and concurrent engineering involves multiple users interacting with virtual and physical objects simultaneously. This complicates things, not just interacting with all virtual objects, but virtual and physical is a mix and match, and that presents a lot of challenges. This use case requires low latency for audio, video, and haptic interaction to ensure that all participants can collaborate effectively in real time. Teleoperated driving involves remote control of vehicles in hazardous environments. This use case demands extremely low latency and high reliability to ensure safe and precise control. The system must support real-time data transmission, including video streaming and sensor data to facilitate remote operations. The specification defines KPIs, key performance indicators such as end-to-end latency, service bit rate, reliability, area traffic capacity, and more to guide the implementation of these use cases. These KPIs are designed to ensure that mobile metaverse services can meet the stringent performance requirements needed for immersive and interactive experiences. By providing clear guidelines for performance, the specification helps service providers deliver high-quality and responsive services that meet user expectations. Security, authorization, and privacy are paramount in the context of mobile metaverse services. The specification emphasizes the importance of regulatory requirements and user consent to ensure data confidentiality and secure service delivery. The system must support mechanisms to expose user authentication results to trusted third parties while maintaining user privacy. This ensures that authorized entities can verify user identities without compromising security. Authorization mechanisms are required for various services, including spatial localization and avatar-based communication. For example, the system must authorize the use of avatars and associate them with specific subscribers. This ensures that only authorized users can access and control digital representations. The secure handling of digital assets is also a key requirement. The system must provide secure means to authorize the use of digital assets and certify their authenticity. This ensures that users' personal data and digital assets are protected from unauthorized access and misuse. Additionally, the specification addresses the need for secure communication channels to protect data in transit. This includes encryption and other security measures to prevent unauthorized interception and access. By implementing these security measures, the specification ensures that users can trust the mobile metaverse services and interact with confidence. Charging. What are some of the charging aspects? Charging aspects are an important consideration, for sure, for the commercial viability of mobile metaverse services. The specification outlines the requirements for collecting charging information related to various functionalities described in the document. For localized mobile metaverse services, the system must collect charging information for actions related to spatial anchors, such as their creation, deletion, or modification. This includes charging for the exposure of spatial maps and localization information to unauthorized third parties. In the context of avatar-based real-time communication, the system must support the collection of charging information for initiating and terminating avatar calls. Additionally, charging information must be collected for transcoding services associated with avatar communication, ensuring that service providers can track and bill for these actions accurately. Digital asset management involves collecting charging information per UE, user equipment, or application for using and managing digital assets. This includes charging for third-party access to digital assets and managing assets associated with specific subscriptions. The specification also addresses the need for flexible and transparent billing mechanisms. By providing detailed requirements for charging, the specification ensures that service providers can implement effective billing systems that reflect the usage and value of the services provided. This helps to create a sustainable business model for mobile metaverse services. Okay, we're into the annexes. Annex A here on this document provides an in-depth look at the concept of mobile metaverse services, defining them as user experiences enabled by the 5G system that integrate interactive and immersive XR media. The term mobile metaverse, quote unquote, emphasizes the use of mobile telecommunication standards to deliver these services. Consumer mobile metaverse services include attending live VR events, virtual shopping, presenting AR content, and situational awareness. These services provide users with immersive and interactive experiences in various contexts, enhancing their daily activities with digital content. Enterprise mobile metaverse services focus on remote working, collaborative engineering, and virtual showrooms. These services leverage XR technologies to improve productivity and communication, enabling employees to interact with virtual and physical objects in real time. Industrial mobile metaverse services aim at improving cost, productivity, safety, and flexibility in industrial operations. Use cases include remote healthcare, AR/VR-based telecom operation, and digital twins for monitoring and controlling industrial processes. Common aspects of mobile metaverse services include enabling localized services, enhancing real-time communications, supporting multiple XR media services simultaneously, and securely managing digital assets. These common enablers ensure that mobile metaverse services can be delivered effectively across different domains and use cases. The annex also highlights the potential for future developments and additional functionalities. As technology evolves and new use cases emerge, the specification will continue to be updated to address new requirements and capabilities, ensuring that mobile metaverse services remain at the forefront of innovation. There's an Annex B. Annex B here provides an example of a framework for digital asset management through the EU Digital Identity Wallet initiative. This initiative aims to establish a sovereign digital identity for European citizens, enabling secure and seamless authentication and document sharing across various activities. The initiative's goals include providing every eligible citizen with a digital identity recognized anywhere in the UE, allowing users to control how their data is accessed and shared. The digital identity wallet will store personal information and certified documents securely, giving users full control over their data. The initiative envisions a wide range of use cases, including identification for public websites, banking, medical services, education, and mobility. By providing a single digital identity wallet, the initiative simplifies the process of establishing identity, reducing the complexity and redundancy of different credentials and verification processes. The initiative also addresses broader concerns such as phishing and illegitimate services by providing a framework for qualifying trustworthy and reliable websites. Additionally, it includes features like electronic signatures, time-stamping, and digital seals of authenticity to enhance the security and reliability of digital transactions. Overall, the UE Digital Identity Wallet initiative serves as an example of how digital asset management can be leveraged to streamline various activities and improve user experiences in a secure and efficient manner. The annex also highlights the potential for similar initiatives to be adopted globally, emphasizing the benefits of a unified digital identity framework. By providing a secure and interoperable system for managing digital assets, such initiatives can help drive the adoption of digital services and improve the overall digital economy. The last slide, conclusion. So in conclusion, this 3GPP-TS 22.156 v19.1.0 spec provides a comprehensive framework for enabling and enhancing mobile metaverse services through the 5G system. This specification outlines the service and performance requirements necessary to support immersive and interactive experiences across various domains, including consumer, enterprise, and industrial applications. Here are some of the key takeaways. 6 bullet points. Number 1, service categories. The specification addresses both location-independent and location-specific services, ensuring that users can interact with virtual and augmented content seamlessly, regardless of their physical location. 2. Functional requirements. Detailed requirements for operational efficiency, avatar-based real-time communication, and digital asset management are provided to ensure consistent and high-quality user experiences. These include mechanisms for flexible service adjustments, coordination of data flows, and secure handling of digital assets. 3. Performance KPIs. Specific key performance indicators, KPIs, such as end-to-end latency, service bit rate, and reliability are defined for various use cases, including traffic flow simulation, cooperative engineering, and teleoperated driving. These KPIs are crucial for delivering the expected performance levels for mobile metaverse services. Number 4, security and privacy. The specification emphasizes the importance of security, authorization, and privacy, outlining mechanisms to protect user data and ensure regulatory compliance. This includes secure authentication, authorization for spatial localization services, and the secure management of digital assets. Number 5, charging aspects. Comprehensive charging requirements are provided to support the commercial viability of mobile metaverse services. These include collecting charging information for actions related to spatial anchors, avatar communication, and digital asset management. The last point is about informative annexes. The annexes, there are 2 annexes on this document. They provide additional context and examples, such as the EU Digital Identity Wallet Initiative, showcasing the broader applicability and potential impact of digital asset management frameworks. So by addressing all these critical areas, the 3GPP DTS 22.156 spec that we're looking at here sets the stage for the successful deployment and operation of mobile metaverse services, ensuring that they can be delivered efficiently, securely, and reliably over 5G networks. This will ultimately enable a wide range of immersive and interactive experiences, transforming how users interact with digital and physical worlds. Thank you for your attention. I'll see you in the next spec presentation. Goodbye.